In this video, we'll be going over estimating square roots. So before we get started, what are square roots? Well, here's the square root symbol, and square roots uses the area of a square to find its side length. So how can I find the side of this square here? One thing I know about the size of a square is that its base and its height are going to be the exact same length. So one question I can ask myself is, what number times itself is going to equal the area? In this case, what number times itself is going to be equal to 25? And the answer to that is going to be 5, because 5 times 5 is 25. Another thing that can help us estimate square roots is using the sides of squares that we already know. And some squares that we already know come from perfect squares. So can you guys list some perfect squares that you remember? Here's a list of perfect squares. And so some of them include 1, 4, 9, 16, 25. And the reason why these are called perfect squares is because the sides of each of these squares are going to be whole numbers. And so using these known sides can help us estimate square roots. So let's look at our first example problem. I want to estimate the square root of 23. Another way of thinking of that problem is, if I have a square with area of 23, what's its side length going to be? The first step in solving this problem is thinking about which perfect squares are right above and right below 23. So the perfect square right above 23 is going to be 25, and the perfect square right below 23 is going to be 16. And the nice thing about these perfect squares is I know what their side lengths are going to be. So the square root of 25, or its side length, is going to be 5, and the square root of 16, or its side length, is going to be 4. And so since 23 is in between 16 and 25, its side length has to be somewhere in between 4 and 5. So which way is 23 leaning towards? Is 23 closer to 16 or closer to 25? I can see that 23 is leaning more towards 25, so its square root is going to be a little bit closer to 5. So when I estimate its square roots, it's probably somewhere around maybe 4.8. And that's how we estimate square roots. Again, we're not trying to look for the exact answer. We're just trying to get into the right ballpark. Okay. All right, let's go over our second example problem. Let's estimate the square root of 52. Or another way of thinking about this problem is, if I have a square with area 52, what's its side length going to be? First, I need to figure out which perfect squares are right above and right below 52. So the perfect square right above 52 is going to be 64, and the perfect square right below 52 is going to be 49. And the nice thing about these perfect squares is I know what their side lengths are going to be. I know that the square root of 49 is going to be 7. And I know that the square root of 64 is going to be 8. And so if 52 is in between 49 and 64, its side length has to be in between 7 and 8. And so which way is 52 leaning towards? Is it closer to 49 or closer to 64? I see that 52 is leaning a little bit more towards 49, so I know the square root is going to be a little bit closer to 7. So when I estimate the square root, it will probably be somewhere around maybe 7.2. All right? Again, it's just an estimate. All right? Let's go over a third example problem. I want to estimate the square root of 13. First, I need to ask myself which perfect squares are right above and right below 13. Well, the perfect square right above 13 is going to be 16, and the perfect square right below 13 is going to be 9. So now I need to find the sides of these perfect squares. What's the square root of 9, or what number times itself is going to be 9? That side is going to be 3. And now what's the square root of 16? What number times itself is going to be 16? And that answer is going to be 4. And so if 13 is in between 9 and 16, I know that its side has to be somewhere in between 3 and 4. Now which way is 13 leaning towards? Is it closer to 9 or closer to 16? Well, it's come somewhere in the middle, but 13 is leaning a little bit towards 16. So the square root has to be somewhere in the middle, but leaning a little bit more towards 16. So the square root of 13 is probably something around 3.6. Right? And finally, let's go over our last problem. I want to estimate the square root of 95. First, I need to ask myself which perfect squares are going to be right above and right below 95. The perfect square right above 95 is going to be 100. And the perfect square right below 95 is going to be 81. Now let's find the sides of my perfect squares. I know that what number times itself is going to be 100. the answer is going to be 10. And what number times itself is going to be 81? That's going to be 9. So if 95 is in between 81 and 100, its side has to be somewhere in between 9 and 10. So which way is 95 leaning towards? Is it closer to 81 or closer to 100? Well, 95 is a little bit closer to 100. So the square root is going to be a little bit closer to 10. So when you estimate the square root of 95 is probably somewhere around maybe 9.7. Okay? So when we're estimating square roots, again, we first need to think about which perfect squares are going to be right above and right below. Since they're perfect squares, we know what the side length is going to be, and that can help us estimate the side of that missing piece.